Greetings and welcome to a series where we discuss how a revolution in physics could soon transform our society. This revolution could reveal that our universe is in fact holographic. In this episode, I will show why a holographic universe would profoundly change our view of each other. In my previous video, I introduced a list of 10 paradigm shifts that separate mainstream physics from the type of physics commonly spoken of in channeled information. And I focused on this one: space and time are an illusion, or space-time is an illusion, as physicists would say. Because in the world of physics, space and time combine to form a single entity called space-time. Rather than living in three-dimensional space, physicists say we are living in four-dimensional space-time, with time being the fourth dimension. Over the past decade or so, renowned physicist Nima Arkani-Hamed has been warning that something very big is wrong, and that space-time has got to go. What does that mean? Over the last few centuries, the laws of physics have been built on a foundation of space and time. Up until recently, the fundamental existence of space and time seemed so obvious that it was beyond question. But now it seems that their existence is not fundamental. They emerge from a deeper reality, which some are calling pre-space-time. This means that the laws of physics would need to be completely revised to replace space and time in the fundamentals of physics with some new theory. But it is not understood how this new foundation works, since it is completely alien to our human experience, which is immersed in space and time.
Only every century or so, on that kind of timescale, do you run into a situation where you suspect something very big is wrong, and something that seemed like an absolutely, completely obvious, hardwired into the way we think about the universe thing has got to go and has to be replaced in some totally shocking way by more primitive, more alien principles and ideas. That's the kind of place we are in our field today.
You're pretty well certain space and time have got to go, yeah?
I think almost all of us are certain that space and time have got to go.
That was back in 2014, and in 2021, Brian Cox was more definite about the consensus. The conclusion that space and time are not fundamental properties of nature, and that they emerge from a deeper reality in which neither exist, is called emergent space-time. If space and time don't exist fundamentally, then something must be combining to form them. So physicists now face the challenge of trying to figure out what spaceless, timeless components combine to form space and time. This recent bombshell puts the field of physics in a very difficult position. It has realized something is fundamentally wrong, but in terms of revising the laws of physics, it is not known what is right, and there is no popular theory emerging to explain it. So physics is now stuck in limbo, further away from a fundamental understanding of the universe than ever before. The best explanation, in my opinion, is a holographic universe, though it would be really difficult for mainstream physics to embrace it, because it requires so many paradigm shifts all at the same time. So I would encourage you to reserve judgment until we have been through all the stepping stones that create this new picture of the nature of reality. Now let's meet the physicist who first proposed that the universe could be structured like a hologram. David Bohm. A friend, colleague and protege of Albert Einstein, Bohm made a significant contribution to 20th century physics. He developed a vision similar to the one I described in part 1, where a revolution in physics could lead to an era of social healing, based on his conclusion that the universe is one undivided whole, that separation is an illusion, and at the fundamental level we are all one. History is showing that Bohm was well ahead of his time. He was the first physicist to propose that space-time is emergent, way back in 1965, at least 4 to 5 decades before it began to gain widespread acceptance. Bohm believed that everything was somehow entangled, but he had no idea how until he came across a budding technology in the 1970s, holograms. In 1980, Bohm brought out this book, Wholeness and the Implicate Order, in which he laid out his ideas of the wholeness of everything and the holographic nature of the universe. Although he passed away in 1992, his legacy lives on, and there are many that believe that David Bohm has laid the foundation for the next revolution in science. The life and ideas of David Bohm are honored in the documentary film Infinite Potential.
He became a scientist, I believe, in order to benefit humanity. I think his mission was always leading up to a transformation for human society, overcoming the fragmentation that we experience, towards having the experience of a new interconnectedness among us all to solve problems together, overcoming the divisions. So in that sense, he represented a truly holistic, integrated vision of a human being. And I think as that, he can serve as a model for future generations.
It's a revolution. It has radical implication about how we live our life, how we interact with the earth, how we interact with each other. And that revolution is unfinished.
This is the revolution of reality I refer to in the title of this series. A revolution that could lead to a positive transformation of society. A scientific revolution in which we realize that we are all one with each other due to the holographic nature of the universe. And so I will spend a bit of time now describing the basics of a holographic universe and how we could all be one with each other. First, let's take a look at the simplest form of hologram. It involves a single color of laser light, which is scattered using a diverging lens. The hologram is a piece of film, which has been prepared with a special photographic procedure. If you hold a hologram at a certain angle to the laser light, you will see a three-dimensional image in the film, in this case a chess piece. Here is a photograph of an actual hologram, with the laser light coming through from behind. The image, that seems to float in mid-air, is fully three-dimensional. In real life, the king is seen to be a few inches behind the pawn. We can see this more clearly if we examine photographs taken from the left of the hologram and the right of the hologram, showing how the pawn shifts its position relative to the king as you move from left to right across the hologram. So how does a hologram turn light into a three-dimensional image? Imagine bringing this hologram close to your face. You are now gazing right into the hologram, and the illusion of a red light appears to be about 6 inches behind the film. What is happening is that the wavy lines encoded in the film bend and focus the light through diffraction. In this way, the light waves reaching your eyes are exactly the same as the light waves that would come from a real red light if it were positioned 6 inches behind the film. A hologram is mimicking the light coming off a real object. Can this also work in full color? Yes, theoretically it can, though there are currently practical limitations. But I'm going to keep it simple and stick with one color for now while explaining the basics. A hologram of a tiny ball gives us a clearer picture of how a hologram works. The wavy lines that produce the image of this ball look like this when magnified, like the point-centric ripples that would spread from a pebble dropped into a pond. This pattern focuses the light into one area through diffraction. It acts like a focusing lens. Now, when we go back to our chess piece, you can rather picture this image as being formed from thousands of tiny balls or dots. Each of them individually looks like this when magnified, but together they form a kind of speckled pattern that extends throughout the film. The important thing to note here is that the ripples that define each dot extend everywhere throughout the film. Now let's see what happens if we have two objects in the hologram, starting off with the simplest objects, two tiny balls. Once again, the important thing to note is that the set of ripples that define each tiny ball has universal extent, meaning that the ripples extend throughout the entire piece of film, and therefore there is universal entanglement. In other words, the two tiny balls are entangled throughout the film. This hologram has two aspects to it: the image source, which is the wavy lines in the film, and the observed image, according to an observer. If we assume that the film is perfectly transparent and the wavy lines cannot be seen. In the image source, there is no such thing as space or spatial separation, because these two sets of point-centric waves are not separate from each other anywhere in the film, because there is universal extent and therefore universal entanglement. In the observed image, the observer sees only the two tiny balls and perceives that they are separated by empty space. So we can see how space emerges in a hologram from a deeper level in which there is no space. Now let's look at a hypothetical full-color hologram of two people. The image source would be an unintelligible speckled pattern, as described earlier, but for purposes of illustration, I'm going to overlay that speckled pattern with the pattern formed by just one of the tiny balls that make up each person, so that the universal entanglement can be clearly seen. Every single particle of person A is entangled with every single particle of person B throughout the film. So is it possible that we are living in a universe that is structured in this holographic way? A universe in which every particle is entangled with every other particle, and every person is entangled with every other person. A universe that is one undivided whole, as theorized by physicist David Bohm. In the world of channeled information, the wholeness of everything is not just a theory, it is reported as a fact that is directly experienced in the higher dimensions. It seems almost impossible to imagine how this could be, until we examine how our reality could be created from sound and light, which I will discuss in the following episode.